Alright, so this is a little video for you all to study with this weekend since you have your big Unit 5B trig test on Monday. So this section, this test covers section 5.5, 10.1, 10.2, 10.4, and 10.5 from your textbook. So if you want some extra practice problems, that would be a good place to go and check out so that you can get a little bit of studying in and some extra practice. So I wanted to kind of start out this video with kind of an overview of everything that our unit was about. We actually did this in class, but I wanted to kind of just reiterate exactly what we are doing in this unit. So the first thing is that we have the Pythagorean theorem. And this is what we use to find the missing side of a right triangle. So it's when we have a missing side. Okay? And the Pythagorean theorem has really nothing to do with angles other than it has to have a right angle because it has to be for a right triangle. Our formula for this is a squared plus b squared equals c squared. Okay? So don't forget about the Pythagorean theorem. We then have our three ratios, and for those of you who may not get my little joke here with the person putting their foot in the pool, that is basically for SOHCAHTOA. Okay, so SOHCAHTOA. SOHCAHTOA is basically how we abbreviate what each ratio is. So, SOHCAHTOA. Sine is going to be used when, and that's for pretty much all of these actually, when you have, when you're looking for a part. So it's to find a part and you are going to be given basically two other parts, and one of them has to be a side. And the SOHCAHTOA helps you decide what each of the ratios are. So, SO stands for sine of the angle equals the opposite side over the hypotenuse. Cosine is cosine of the angle equals adjacent over hypotenuse. And tangent would be tangent of the angle, or TOA, tan of the angle, switch colors here, equals opposite over adjacent. Okay, if I have momentary pauses in this video, I am doing this from home, or if you hear children run in screaming, so sorry, but my children are playing. They have a little message for you at the end of my video, by the way. So I was told that my videos were not exciting by some people that will remain unnamed in 6th period. So I don't want to hear any comments from Kareem in 2nd period. I don't want to hear any comments from Zach in 4th period, and especially not Dan in 6th period. Anyway, so 30, 60, 90. This is, of course, you know all of the, what are these? These are all the angles. So these are only used to find missing sides. That's it. Kind of like Pythagorean theorem. And you're only given one side. Okay, so the relationship here, I'm going to zoom in a little bit more here just to make it a lot easier for me to write. So in a 30, 60, 90, if I have my triangle like this, the short side that is always opposite the 30-degree angle is going to be x. So to get the hypotenuse, which is opposite the 90-degree angle, I'm going to multiply by 2. To get the long leg, which is always opposite the 60-degree angle, I'm going to take x and multiply by root 3. So if you have the short side, it's easy. You just multiply. If you don't have the short side, that's when you have to work backwards. So let's say I was given the long leg. Then I would have to work backwards and divide by root 3 to find the short leg. If I had the hypotenuse, that means I'd have to divide by 2 and work backwards to find the short leg. So everything's kind of based off this short leg right here. Okay, so then we have the 45, 45, 90 triangle. And in the 45, 45, 90 triangle, again, I'm going to zoom in here just to make it easier for me to write my triangle. I'm doing this on my iPad, so here we go. We have our 45, 45, 90 triangle right here. My two legs are always congruent in a 45, 45 because this is basically an isosceles right triangle because these two angles are congruent. And to get the long side, I take x and multiply by root 2. Okay, not 2. That's a really common error. I've heard a lot of people say, multiply by 2. No, don't multiply by 2. Multiply by root 2. Now, if you have the hypotenuse, then you have to work backwards, basically, to find each of the legs. I really hope you can't hear my kids screaming in the background because they're playing really loudly downstairs, and it seems to be coming through the walls, so I hope you're not picking that up. If you are, well, then you can hear how loud my little children are. In any case, we then have the law of sines and cosines, which is probably the most fresh in your head. Law of sines and cosines are used to find missing parts again, but it's for any triangle. You use the law of sines if you have the combination of angle, angle, side, and this is in your review as well, or if you have angle, side, angle. Okay? There is a special exception of the side angle, but you're not going to really see that at all. So don't bother with that. Law of cosines is the hard one is side, side. And that's actually what I gave you as an example. The side. So try that one. That's a good one to try. Okay. And then the other one is side, angle, side. And this is when you don't have a pair. You only use sines if you have a pair. Okay. Law of sines is just your proportion. So sine of an angle over its opposite side equals sine of the other angle over the other opposite side B. Law of cosines is just the side you're looking for or the side that's opposite the angle you're looking for. So in this example, you'd actually start with 10 for that. Equals the other two sides squared minus 2 times the sides times the cosine of the angle you're either looking for or the angle that you're given. Okay? So that's kind of a broad overview of this whole unit. I mean, every problem that you saw in your review packet uses one of these concepts.